All right, let's do this. All right, I hope you're ready. All right. Gauss's law. Let's begin at the beginning. Wait a minute. Actually, no, we can't do this. Yeah, no, I got a little foolhardy and over exuberant for a second. I'm sorry. You can't do optics this way. It's not that it's too hard and that we're too lazy. It's that it just doesn't make any sense, okay? So there are very few cases of things that actually happen in optics that you care about that you can even solve analytically, that you can even get a solution to. Most cases are so complicated that there is no solution. You can't actually write down the solution. In the few cases where you can, for instance, a plane wave diffracting around a sphere, it's called the Mie solution to the electromagnetic wave equation. The answer is so complicated you get no intuition for it. It's an infinite series of terms, and it's full of Bessel functions and Hankel functions, which are really no more complicated than sinusoids, but we aren't as familiar with them. So it's just this big stringy mess that you have no intuition for. And what do? We take it and we apply approximations where it actually makes something that's useful. So really, there's just no reason to do classical optics as field theory. It doesn't make any sense. The one time you want to do optics as field theory is when you're doing quantum optics and quantum field theory, and we're just not there yet. Right? So, but don't worry, we're going to make approximations. We're going to use techniques beyond field theory, but it's still physics. Interference, diffraction, scattering, it'll be very physicsy. We'll take 1 week and do geometrical optics, and that's not physics, that's just geometry. But we have to do it because that's optics, right? That's what lenses do. But we'll do plenty of physics, I promise you. And the closest we'll come to doing optics as field theory will be, we will very carefully do detail of what happens to light at a dielectric interface. And you get something called the Fresnel equations, and you will wish we hadn't done it, I promise. You will beg for mercy before it's over. And I guess the other thing I'll let you know is, since I've made this decision that we're just going to do optics the normal way, I'm going to do one board. The next board will be sort of your introduction to how we got from Maxwell's equations to a wave equation and what Maxwell discovered, but just in one board. If you're interested in seeing it in more detail, if you go back to my previous class, 102X, Introductory Electricity and Magnetism, if you go to LS10, that has that in it. If you want to see how you get what all the vector calculus means and how you get from the integral form to the differential form and really see the details of driving the wave equation, it's right there. So 102X, it's archived on edX, and you can look at learning sequence 10. But really, if you're just trying to learn optics and understand how light works, there's just no reason to do it. So we're not going to.